This is our Alaskan Fisheries Showcase by Sarah, Lexi, Brandy, and Mimi. Our showcase will focus on the Alaskan fisheries from 1987 to 2020. The datasets show many different relationships and trends that can be seen in our visualizations. Our showcase will focus on 4 datasets of fish in the Alaskan region, including halibut, herring, sablefish, and salmon. Questions about Alaskan fisheries. Is there a correlation between salmon and the other 3 fisheries for the wholesale value? Has there been a trend in the population of each fish species over time? Has the net weight of the fish affected wholesale value over time?
Before we begin any data project, it's very important that we make sure we have the best quality data possible. There's a saying for that. It's called garbage in, garbage out. So we really want to make sure we don't put any garbage in. A good source for data is typically going to be scientific websites, particularly government scientific websites, and that is where we're getting our data from. The first one we looked at was the National Oceanic and Atmospheric Administration, which is a division of the United States Department of Commerce. We learned a lot about how fisheries are organized and managed from there. We pulled our actual tables from the Alaska Department of Fish and Game from the alaska.gov website. Now, they had a lot of interesting reports about fishery management that they had already done themselves, but we wanted to do our own analysis. At first glance, you might not be aware that they had all that data on their website. But as I've highlighted on the screenshot, if you go several submenus down, you can get your hands on some of that raw data. And we were able to download those tables, and then we were able to put them together and do some of our own analysis. This is typical for a lot of government websites. The raw data will be there, but it's not going to be advertised. You really have to go look for it. Once we downloaded our spreadsheets, we needed to get them into a manageable format for analysis in Tableau. The first thing we wanted to do was to take all those different spreadsheets and combine them into a single workbook. Once we did that, we were able to upload it into Tableau and make it a little easier to work with. Because those tables did not have a whole lot of data problems, we were just able to use Data Interpreter to fix those problems. If it had had a lot more problems, I probably would have chosen a different program. We could have used Tableau Prep. I personally like RapidMiner. It has a lot of different options for dealing with a lot of the different problems that you can have. The biggest problem with this data set was some missing values. Data Interpreter had no problem filling in blank spaces with just null values that the software is able to handle easily. Um, Data Interpreter was able to scan it for all other issues. Then we were able to sort it and aggregate the data to make it easier for analysis. The salmon species were already aggregated in this particular form, but if not, we could have used binning to put them all together into one sheet, if into one field if we wanted to. That is just one of the many things we can do with our pre-processing. There's a lot of other issues that can come up that Data Interpreter can handle, but sometimes you're going to want a more robust program for that.
Graphics and visualizations. In the first visualization, it shows the net weight of each of our 4 fish over the years. The trend line for all other fish, herring, sablefish, and halibut, is shown going down, while salmon is the only one with a trend line going up. The second visualization shows the wholesale value of each of the fish, salmon being our highest wholesale valuer. This bar graph shows the net weight versus the wholesale value. While salmon towers over the values for the other fish, it can be noted that herring is the only fish where its pattern is different, in which net weight exceeds wholesale value. This visualization shows the comparison of net weight versus wholesale value over time. Each section for the graph represents a fish with dual comparison of net weight and wholesale value, and time is measured by year from 1984 to 2020. This visualization shows the net weight of fish over time by year from 1984 to 2020, with a separate graph representing salmon. At maximum for the graph representing halibut, herring, and sablefish, it reaches over a value of 160 million, while the increments on salmon is much more drastic, standing at over 700 million.
We were able to conclude a few different things based on our data analysis. First is that we noticed a trend in the population of each fish species over time. Herring, sablefish, and halibut populations have been decreasing over time. However, the salmon population has been growing. A couple reasons for the declining fish population could just be that they are experiencing episodic collapse and recovery, as some fish species do, or it could also be related to overfishing in other parts of the world. But our data set focused specifically on fish populations in Alaska, and Alaska currently does not have a problem with overfishing because they are pretty sustainable right now. So we would need further data analysis to dive deeper into why the fish populations have been declining. We also concluded that the wholesale value of sablefish, halibut, and salmon is more than twice its net weight, but herring's wholesale value is actually less than its net weight. One reason for this could just be supply and demand. There could have been a higher supply of herring at the time and less customer demand, which may have caused the prices to go down. But again, we would need further analysis to know for sure. And finally, although salmon's wholesale value was the highest, that is because the salmon population is the highest. Salmon's wholesale value compared to its net weight is about the same proportion as the sablefish and the halibut. Here are the sources that we used for our research and analysis. Please feel free to leave us any questions you might have or any feedback you'd like to give us. Thank you for watching our presentation.